right, internet, here we are. So, this is the next video of the Secereum Bootcamp series. And this time we're going to do Solidity 101 as well as Solidity 201. So if I open up this handy dandy section, you can see that there's 201 and there's also 101. So first things first, there was a huge struggle with reading these, both of these Substacks. A lot of the content was new because I've dabbled in Solidity by doing crypto zombies as well as a series of other small projects, but I've not gone this deep and basically reading the documentation. To be honest, most of Solidity 101 and Solidity 201 is just a straight up copy and paste from the Solidity documents. So if we do Solidity documentation, so here you go. If you want, you just read this. Basically, just read this entire thing. If you read all this, then you would have basically have read most of what's in there via these two things. With that being said, word to the wise, or word to the people that have failed when going through this, is try not to, I guess, yes, read it from front to back like a narrative, but don't be too hard on yourself if you only remember 2% of it. I have some things here in my notes that I wanted to kind of mention here during this video to kind of help you not feel so bad when going through this, or at least help me not feel so bad going through this. So first things first is I did read it from front to back, but like I've stated here, I probably only remember 2%, maybe 3%. A lot of it is very dry, and a lot of it is just straight up documentation. So there's not many intuitive ways for us to abstract these ideas into our heads unless you have tons of experience with Java. I think it's like C+, and a series of other those languages. Maybe some of this stuff will resonate. But me, I only have experience with Python, JavaScript, some HTML, CSS, and then a bit of Go. But even with that, I only picked up maybe, I'd say 35% of it was not new. It was kind of common ideas from other languages ported over to Solidity. But I've not dealt with many of like the C# or C or any of that stuff. So that was a lot of new steep learning curves for me. So first things first is don't get too hung up on not being able to understand everything. 2% is fine. The other thing that I realized when reading through this is after I read both 101 and 201, I actually went back and reviewed both, but I skimmed them quickly. And my goal with skimming was basically trying to figure out what topics were repetitive and mentioned quite often, because if they were mentioned quite often, most likely they're important. So those were the topics that I actually dove a bit deeper into, did some Googling, found other explanations that weren't just the documentation, found some videos, found some kind of graphs, found blog posts, things like that, to really get multiple perspectives on how to explain that concept. So first skim, then Google. Next thing is basically the point I've already made. So most of this is just documentation. So that's kind of that point. And the last thing is this YouTube channel here. So Smart Contract Programmer. There's a specific playlist that he has that's basically walking through Solidity 0.8. You can see it here. And my recommendation is very high on this, is to basically go to his playlist and watch his playlist of Solidity 0.8, because he explains most of the concepts within the material that's inside of here. I wouldn't say he covered all of it because that would be kind of impossible, but he covered most of it. And a lot of his explanations are really, really good and really thorough, because he'll explain a concept, show you within code, and then he'll even test it and say, this is what it looks like once tested, and here are some of the results. So 1000% recommend going to check out his content, because he puts a lot of work into that, and it's definitely super valuable. So somebody like that should get acknowledged. That being said, we will strike this out, because kind of like this. I like striking things out with you. Makes me feel like I'm making progress in this video. Okay, so that's the preface and the intro to kind of talking through. Don't be hard on yourself. There's a lot of content here. You're never going to remember all of this. That's why most programmers are just really good Googlers. So that's that. Next thing is I want to dive into the content. We're going to start walking through mainly some of the things that I found new, interesting, and something I either struggled to understand and finally understood, or struggled to understand and still don't truly understand, but I wanted to call it out anyways. So first things first, at the very beginning, they talk through basically the source file structure of a Solidity file. And they kind of talk through I think this is for a contract, yeah. there's quote unquote best practices and best patterns for developing contracts and things like that. One of those best practices mentioned within this 101, I think it was, for Solidity, was the structure of a file and how that file should be structured in this method. So going downwards, we should have state variables at the top, events, modifiers, and then constructors, and then finally functions. So that would kind of lead into that one. And that's just one small thing. But I guess one thing I wanted to bring up on this piece here is I started listening to a series of video kind of hangout lectures. And I'll actually pull up one to show you what that looks like. If I go here and show the entire internet, my history. So I think it was like something Fridays. Yeah, I watch cat videos. Don't judge. You can see that I've watched a lot of smart contract programming dudes. Here we go, this one here. So this group here, Solidity Fridays, that's what it's called, Solidity Fridays. And they're talking through a specific ERC kind of proposal. And I would say probably 90% of the stuff that they mentioned here I didn't understand. But one thing I did understand when they were speaking about it is best practices and patterns. And this is something you'll commonly come across if you're not necessarily deep within kind of like the development community, is when you find somebody that's very deep into a specific programming language and they've been in that field for a bit and they're kind of labeled as experts, they'll start to talk about best practices, patterns, and concepts that are more abstract than just the kind of nuances and the grammar and the syntax of the programming language. And specifically in that conversation, they started talking about that and they were mentioning nuances of it. And I thought it was really interesting to hear them speak about that. Even though I didn't understand most of it, I can still understand the abstract concepts of what was mentioned for best practices and patterns. And that's kind of where this comes into play. So if you're interested, you should check out the videos from the Solidity Fridays from Linum Labs. All right. After that, I came across Pragma. So I've come across this historically because I've done Crypto Zombies, which is another recommendation I'll make here. So Crypto Zombies, here, they basically have a series of games and courses. And you can see I've done all of these. But what it is I'd recommend starting with this one first. And it's a simplistic way to actually interactively learn Solidity through programming. It's kind of like an NFT / crypto zombie game where you can create unique zombies and they kind of eat each other and morph into different things based off of genetics and stuff. But it kind of walks you through how to utilize Solidity in a hands-on method. So that's another recommendation. And inside of there, I learned a lot about Pragma. But within Solidity 101, they mentioned a few other things that I've not heard about. And those things that I've not heard about are the additional uses of Pragma outside of just the compiler version. So if we look here, we can see the thing that you'll see most likely, is going to be the compiler version, where it's mentioning basically Pragma, Solidity, and then it mentions a number. So this is the major version. I think it should be major, minor, and experimental or something like that. But since they've never actually had a major version published yet, the center one is major and this is minor. And when looking at these Pragma write-ups, you'll see that there are a variety of different options for these carrots and other things. So if I come down here and show you this kind of picture / code snippet, you can see this carrot. And this carrot basically states that this compiler version is compatible with 8 and above. So basically from 8.0 to 8.9 or 8.10. But once it gets to 9, then it would be compatible with 9 as well. Okay, there you go. So 8 and up. That's what that means, the carrot. Here we have basically a sandwiching of saying anything equal to or greater than 6.0 and anything less than 8.0. So it has to fit within inside of these barriers for that compiler version to actually function and work correctly with that code snippet. So that's that piece. The ABI version. So ABI is basically, I forgot what the acronym stands for, but it's the interface between the higher level Solidity code and the bytecode that's then run on the virtual machine. So it's basically translating that down. And the default today is going to be V2. And you don't even have to write anything there. That's just already there. And most of the time when I've looked at code snippets, I've not seen the ABI coder at all. So this is something I've not seen much. And then this is something I've definitely not seen at all. But that's probably because I haven't looked at much Solidity code, but I'm sure I will eventually one day. And this is basically an alternative for Pragma where you can do experimental different types of things. And this checker is a security checker, so it does additional security checks on your behalf. And there's basically a way to run experimental tests and different types of features within the compiler that you can then experiment with. So there is Pragma. That's how it functions. We've talked about this. All right, cool. State variables. So state variables, there's different types of variables. So there's a few different variables, and I think I actually have a code snippet somewhere that I'll share with you. But quickly, just high level, there's G for global variables, S state variables, and there's local variables. And global variables are basically accessible to everybody. So that's getting like the block number, the block timestamp, things like that. State variables are usually written within the contract. So you can see state variables here, accessed by all functions of the contract whose valuables are permanently stored on the blockchain. So these variables are actually stored on the blockchain. So that means gas is associated with the cost there. Another thing about state variables is there's different types of visibility, similar to functions, which is another thing we'll talk about down a bit lower. But with visibility for state variables, as well as functions, I'll quickly kind of walk through these definitions. So public here basically states that the state variable itself sits within the contract. It's kind of like the contract's interface with other things, and it's accessed internally as well as via messages. So you can have these public variables be accessed by messages from outside the contract. So that's usually coming from another contract or an externally owned account, human. Next one is internal. So here we can see it's basically saying that this is accessible within the current contract, or it can be accessible from contracts deriving from it. So if this contract inherits another contract, then that contract can then access this internal state variable. Last is private. So misconception with this sometimes when people see it is they assume that it's secure or it's private, somebody can see it. But this private state variable is actually accessible by humans. You can see this within the code. So it's not actually quote unquote private. It's just private from other machines interacting with it when everything is executing. Here you can see that private state variables are accessed from the contract they are defined within. So there are no derived contracts. So even if this contract is inherited by another contract, the state variable that's private is not accessible by that. These are the different types of visibility that are available for that. And one kind of, I guess, mental picture I had in my head when thinking about this was concentric circles expanding. And let's make this a bit bigger. And here you can see we have some circles. And the idea I was thinking is that the private state variable here is going to be in the center, right? This is only accessible by the contract that sits within and nowhere else. This section here would be our internal variable. So this one here, internal variable, is accessible by its contract as well as any contracts it's derived from. Last one here is going to be the public state variable. And that's going to be accessible from all the stuff that these two are involved with, so the contracts inside of as well as the contracts derived from it. But it's also accessible via messages that come from externally owned accounts or smart contracts. And that was kind of a simplistic way for me to kind of understand that piece. With that being said, we've finished state variables. We're cruising along. Look at us. So successful. All right, this part was very short, and I left it short because I dug into it, but I couldn't find. I could find the answer, and I'll show you the answer that I came across. Let's find it in the code snippets here. Constant. I think this is right. Probably Google's easier than this. Probably is. Well, here we go. Okay. So in this explanation, they talk about constant and immutable variables. The point that I want to make here is that these specific variables have been mentioned inside of, I think it was Solidity 101, mentioned that these two variables are lighter on gas. So this is a preference for some developers to utilize these variables when they're relevant to be used. I tried to figure out why specifically they're lighter on gas. I found a few answers in here, and the main answer here is basically stating that the expression assigned, and you can see it here, the expression assigned to it, referring to the constant variable, it assigned is copied to all the places where it is accessed and all the reevaluated each time. If I could read in public, that would be easier, but public reading is not fun. My assumption here is that we have a value. So say that value is, let's call that value Rick. That's a string, right? This is then, say, assigned, and this is a horrible way of explaining it. So we could say Rick is assigned to A, is our variable, our constant variable. So what I understand here is basically the expression is referred to as the variable when it states expression here. This is assigned to a copy. This is assigned and it is copied to all the places where this is accessed. Anytime Rick the string is accessed, then A is basically copied to all these locations. So instead of having the actual string copied to all these locations, just the expression itself is. And when everything is executed, I'm assuming where it's copied to, it's then referred back to the string where it's stored on the blockchain. So kind of didn't understand that piece, did my best to explain it to you. Just know immutable and constant state variables are considered lighter on gas for some amorphous reason that I can't understand. You're welcome. Next, state variables and local variables. So these are two code snippets to show you kind of what that looks like, but I also have a bunch of stuff in here I want to show you. We will copy this stuff over to another file, I think, or we'll just leave it here and you ignore everything else except for what I tell you to look at. But before we do that, we'll look at this because these snippets of code are not in there. Here it's showing you an example of what a state variable looks like in context as well as local variables. We zoom in here. You can see our state variable is defined within the contract, but not within the constructor or a function. Here you can see we have our state variable being called out here, and we should make that pink so you can see it. And our state variable here is being defined within the contract. Functions have not been created yet, so it's not inside of the function. Hence, the state variable is going to be stored on the blockchain. That's going to cost us some gas. Down here, we can see that we have both a state variable as well as a local variable. And the local variable is going to be temp bar, and we know that it's local is because it's inside of the function, not inside of the contract. Additionally, we can see that this variable is derived from the two parameters that come into the function here. And that's just a simplistic way to know the difference between the two. State inside of a contract, local inside of a function. That's that. Can't check those off because they're pictures. Wait, we can, you know? We can, internet. We need progress. We need dopamine hits. There we go. I got our hits. This was a really cool chart that I wanted to show. We've seen a few functions, and I specifically will pull up a function here so you can see what it looks like just at a high level. Here we have a function. Let's go to this one maybe. This one, sure. In a function, we have a few different things. So we have function, right? So we have the function kind of declare. Then we have the name of the function. Inside of here, we can have different parameters. Those parameters need to have usually a data type and then a name, right? Then we have kind of declaring its visibility, as well as kind of how it modifies things if something is returned. So if there's like a return piece, the parameters that are being returned, and then a whole bunch of stuff inside of it, the body of the function. I wanted to show this because if you see the context of an actual function, this diagram will make more sense. If not, it might be slightly confusing. So here, let's zoom in a bit. And I really do like diagrams like this, mainly due to the fact that they help you understand kind of where everything sits and how it's connected and cohesively, I guess, evolves throughout the process. So like I mentioned, we have our keyword up here, function, which kind of ignites everything. We have our function name. We then have the parameters, as I mentioned previously here. Inside of that, we have our data types, our parameter names. In addition to that, and you can see there's a comma here, basically stating that there's a comma between the two. After that, we have a few items. So we have the visibility, like we've talked about already. So we have the visibility of public and external, and also private and internal. These are all options that you can have for this piece here. Lastly, we have those pieces that I mentioned around if you're modifying something or if you're viewing something or if you're not touching anything. And that's usually referring to state. So these are just some options you can put here. Then we have the returns piece that we've already talked about, where if there's something being returned, we have some more parameters that have to be returned if this is mentioned. And then last, we have the body of the function. So having this flow, kind of seeing how everything is connected and how it all goes together, is for me, it's a really intuitive way to kind of understand what's being discussed. All right, we did it. We did it. Look at us, we're making so much progress. It's almost like I know what I'm talking about. Cool. All right, so parameters, data type name, I already mentioned that. That is referring to that piece inside of here. Return variables, we've talked about that, but we will zoom in here for a second. Maybe just make this bigger instead of zooming in. Ooh, that's too big. All right, let's make it a little smaller. Okie dokie. So return variables, I wanted to mention this here, is the fact that return variables within a function can have two different approaches or methods of doing this. And what I've noticed and what I read and came across were these two concepts here. So we have one method here, and then we have one method here. We'll start with this first one. Here you can see there's returns. Then we have the parameter that's going to be returned here. But as you can see here, the difference between this bottom method and this top method is that there's a name. And here we're basically restricting this returns to a specific expression or alias, saying that whatever is returned has to be named result. Here, we're just stating that we need a uint, so we need an integer that comes back. And we don't really care what the name of it is. It could be Ricky Bobby or Rick and Morty. It doesn't matter. And those are the two different methods that you can see. So you can see we have a return counter, so we're returning counter here, but here we're returning result because remember we said that it has to be a result that's returned. So we have to basically take that counter and shove it into a result. So I learned that. I'm not 1000% sure why that is the case, but at least we understand that it exists and it's a thing. So the next thing after you understand it is you got to figure out why. But like I said, we basically read the entire documentation in a couple of days, so be kind to yourself, internet. With that, next. Modifiers. This is one thing that I found quite interesting, and if I go back, no, I'll go here. All right, this image here is a good one to kind of explain what modifiers are and how they function. Hopefully this is big enough for you to see. If not, then too bad. So you can see the explanation here. Basically states that black on black is not going to work. Here, so modifiers, what they do is they basically change the behavior of a function based off of a condition that was either met or not met. So we have a function, and we're going to do this check before that function actually executes. And inside of the modifier, I may have to zoom in for this so you can actually see. Oh, it's so big. All right, internet, hopefully I'm not breaking your brain right now. So we're going to look at this top box here first. And here we can see that there's a modifier. And I'm sure I could have put this in VS Code and made it easier on both of us, but I haven't, so we'll do this. Modifier, we have to define the modifier. So we have our contract here. Remember, we have our contract, we have our state variable, we have our constructor, we have a modifier. So the modifier here is defined for the function. And inside of this contract ownable, we're creating a modifier called onlyOwner. And that modifier is going to do a check. And that check is going to be basically saying, is the sender the owner? If so, or if not, then send back access only for owner. But if it is true, then you see this weird little squiggle here. So we have an underscore and then a semicolon. That basically is inside of every single modifier. And what that means is that I want you to continue the function if this is true. So if we meet this requirement, then keep doing the function. Keep going forward on this function. If we go a bit down here, we can see that our modifier, onlyOwner, has been included in this function here. And also, an important point to point out is we have a contract called Ownable, and this Ownable contract has been inherited by my contract. So my contract is Ownable means that you're inheriting all the functionality from Ownable, or most of the functionality from Ownable. And then down here we can see that this function is actually calling this modifier from that contract. And this is basically stating that in this situation, I want you to make sure that this requirement is met before this function actually executes. So if this function only access, if this doesn't meet requirements, this isn't going to go. But if it does, it will. And that is the concept of modifiers. We're modifying the functionality of a function if it executes or not. The functionality to function. Crack myself up, internet. All right. Next is visibility. I think we have code for this. I'm pretty sure we have code for this. Anyways, visibility. So this visibility is referring to the visibility of a function, not of a state variable. They're very similar in nature, but there's a few differences. We'll read these out together. And the one point I pointed out here at the very beginning actually was somewhat insightful is visibility is around who and how others can interact with my function. So who can see it and how can they interact with it? That's the visibility piece. So here we have public. So this is very similar to the state variables, where it states that this is the interface for the function. And this interface is basically saying that this can be called internally from most of the other contracts inside of this kind of this application, this DApp, as well as messages. So that means that EOAs and CAs can potentially call this message. EOAs, humans, CAs, smart contracts. Now the external one here is slightly different than public. It does everything public does, but it states that the external function cannot be called internally. It can only be called externally. So other contracts via transactions, not messages, but transactions, this external function can be called. So that's going to be usually somebody sending or withdrawing funds from a contract or another person. Next is internal. Here we can see that internal is basically stating we can, this is from the contract or the derivative of the contract, and then private's the same as last time. So internal is saying that this function can be interacted with from within the contract or from contracts that inherit this contract. And private is the last one where we've already discussed this, where this is not private in the sense that humans can't see it. This means that other functions and machines can't see it. So we're stating that this function can be accessed only within the contract that is defined inside of, hence defined. And if we actually go to some of this code, I have a bunch in here and I want to make sure that you can see what I'm talking about. And the point I'm trying to make with this one is visibility. Okay, func visibility, cool. All right. So this snippet of code is showing one variant of this. So you can see that this is a public function, which means that it can be viewed within its contract that it's defined, the inherited contracts, as well as messages. In addition to that, so we have, this is the message one, not external. And then we have our view, which is view and pure, which I don't know we've talked about yet. We may come to this soon, but we've not talked about this. We'll come to this soon. And then the other thing I wanted to show is, and I think there's another breakdown here for you, internet. Yep, we've not come to this. I've jumped ahead, and I'm sorry for that, truly. So we've completed this piece, and yeah, we're going straight into it. Groovy. See, I'm right on track. All right, before I jump into this, there's actually a great video from Smart Contract, the one that I've told you basically to watch every single one of these. And inside of this, I think he's done an amazing job explaining the difference between view and pure, and not only shows you the difference, but actually executes. Oh, no. Sorry, man. Gotta be quiet. And also, he executes and tests your knowledge. So he goes through here, explains specifically what it is, then asks you, based off of what I've taught you in these upper two functions here, I'm going to test you. I'm going to quiz you. What is this? And he's going to do the same thing here. He's going to say, what is this? I love that. I love that they're immediately making you feel gratified for the work that you've done. That's a good one. So what are pure and view functions? Pure and view functions are around how state is read, modified, and touched. If we look here, we can see that default. So default means that you've done nothing for the function. You've not mentioned pure or view on it. You've just let it be. It's empty. That means that this is read and write. By default, all functions have the opportunity to both read the state of the blockchain as well as modify the state of the blockchain. And we've already talked about state transitions and state in ETH 101. So if this is new, check that out. Next one is view. View is a little bit more restrictive. So here we're saying we can only read the state, we cannot modify the state. And then we're going to go one level down to pure, and pure is even more strict, saying that you're not allowed to read the state and you're also not allowed to modify the state. And these are all associated to the functions. So one more thing here, if we come back up to view, we can see that I mentioned that reading state means that you're reading data from the blockchain. So I wanted to simplify that and really kind of bring it back down to earth. Instead of just saying abstract terms of state and things like that, you're just reading data from the blockchain with that concept of read state. And back to the code, because I promised you that this is not a trick. All right, these state variables, remember the state variables are stored on the blockchain. It's data that's stored. So this data is on the blockchain. We have two functions down here that both have view inside of them, and that means that they're going to read data from the blockchain, not modify it, because these aren't defaults, but these are views, slightly more restrictive. Here we see that num1 and num2 are mentioned, same as they're mentioned here. So we're calling that in here. And also we're gonna do some manipulation here, and then we're gonna send back the product and the sum. So here we're viewing and we're not modifying, we're reading the state, and then we're gonna create our own separate variables here that are local. Here's another example of this where we have another view, and instead of actually pulling the state variable, we're actually pulling global variables. And remember how I mentioned that there's a concept of global variable? So I think I do have a mention of this somewhere, but we'll cover it now just in case. So global variables, like I mentioned, are globally accessible for basically everybody, and they're generic global variables that are pulling information, usually some sort of metadata or straight up message values and messages, I guess, from the blockchain. Here you can see we're getting the block number. You can also get the block timestamp, so we can say time. In addition to that, you can get, I think, the block hash, or the most recent block hash. You can get, I think it's a chain ID, and then a whole bunch of other stuff you can pull with global variables. And here you can see that this view function is actually pulling that information via block number and stuffing it into this variable here. And that is a view function. And here we got a pure one. So pure functions. This pure function, you can see there is no state variable it's pulling from. There is no global variable it's pulling from. The only items that it's manipulating and playing with are the items being passed into that area. So we have local variables, but these are not state variables. And then we have inside of that different kind of calculations we're going to do. So the product is times, obviously, in addition. There is no reaching out to the exterior world. We're doing everything inside of that function, and everything, once that finishes, it's done. There's no reading state or modifying state. All right. That is done. And here, so I have the same code. We're not going to review that because we've already reviewed it. Next, override versus virtual functions. When I first read this, I was so confused beyond belief. And after I did some Googling, I then figured out what it meant. A simple way to possibly explain this is saying that we have a virtual and override. So we have virtual functions, so let's say V, and override functions. Override functions basically override virtual functions. And virtual functions are functions that are submissive to the parent contract that's inherited it. So this override function is inside of a contract 1, and this is in contract 2. This contract has inherited this contract, meaning that it's allowed to override this function as long as it's labeled as virtual. Let's see what this looks like. First things first is let's look at inheritance. So here we have contract base 1, and here we have contract base 2. Both of these are labeled virtual. Let me expand that last one. So here we have virtual, mentioned here, virtual. Both of these foos are virtual functions, and these are both contracts. This contract I've inherited has both inherited base 1 and 2, and inside of this function, it has a function named foo as well, but this function is going to override both contracts base 1 and 2, the functions that sit within those. So that's basically stating that any calculations or any manipulations that I do within my final function that's inheriting from those contracts is king. So we can define any type of calculations in this function and it overrides all the others. But that only works if the functions inside the inherited contracts have the virtual setting up there. And this link links to an interesting blog that kind of explained it to me, which was useful. Another thing I wanted to show within the code snippet, let's make this small again so you're not looking at anything but what I want you to look at, is an example here from Zeppelin. So Zeppelin has a ridiculous number of so much information. And actually, one thing I'll point out here, actually, we're talking about this, in 201, I would say half of this entire piece, so there's 101 mentions here. Of the 101 mentions, it's got like 50 of them is Zeppelin contract mentions. So if we just do Zeppelin, yeah, you can see starting at 146. I don't know, I want you to see this. I want you to see this. See this bar over here? Right here? See this bar? All these little pink marks. I know my face is somewhere around here. All these little pink marks. That's all Zeppelin content. That's almost 50% of this entire Substack thing. It's basically just copy and paste from Zeppelin's documentation, talking about all the different ERC commits and contracts, which is useful and is insightful, but not the most exciting read, if I could say so myself. What I wanted to show here is a real-life example of a override in virtual section. And specifically, you can see with this code snippet from Zeppelin for this transfer function is they not only have virtual, but they also have override. Why would they do that? Well, from what I understand is that this is somewhat of a precaution. So if I inherit this function from a contract that I've inherited from Zeppelin, which happens all the time, I want to ensure that I can override this transfer function if need be. But if I just copy and paste this contract from Zeppelin, which I'm sure happens a ridiculous number of times, which is good because Zeppelin has really secure contracts, then I need to ensure that my transfer function, if I do copy and paste that, overrides any other contracts that I inherit that have this transfer function, if that's my top function or my top contract that I want to care about that I've copied and pasted from Zeppelin. So it's somewhat of a mitigation factor for Zeppelin to ensure that the function is doing what you would like it to do both ways. And remember I told you I was going to talk to you about, state, local, and global? Well, it's that time. It's that time, internet. And let me make sure that I'm not lying to you. We've talked about this. All right, we're here. Congratulations, you made it. Some other interesting links that I wanted to share are all from our friend at the same YouTube channel I've told you all to watch. He's basically created 3 videos back to back for global, state, and local variables, explaining in succinct manners that are way better than I can explain it. So just go watch him explain it and ignore this piece of the video. With that being said, I will try to explain it. And I'm going to explain it through looking at code snippets. So if we go here, we can see that there's different mentions of it. And here I've created a few different variables. So we have here sits our state variables. Remember, that's sitting inside of the contract. Those state variables are going to be stored in the blockchain. Here we have our local variables that will not be stored in the blockchain, and they're ephemeral, so they disappear after the function is executed. And you can see those areas here. Actually, the same applies here. And then down here, we can see that we're actually modifying the state variables within our function. This is referring up to here. And then last but not least, we have our global variables, which are being mentioned within inside of a function, but they're not local variables. Reason being is that message.sender, block.timestamp, block.number, all of these here are, like I said, global variables that can be called to get data from the blockchain in different blocks. That's the big discernment between the 3. We have local variables inside of functions, state variables inside of contracts, and then global variables that everybody can access to get information about the blockchain. Groovy. We are going to check it off. We're going to check it off because we love checking stuff off. All right, next. The next piece here, there's a few different bits, and let me kind of, let me take a step back. Don't look at any of this stuff. Internet, don't look at it. Actually, I have an idea. If I make this super big, look at this. It's going to be crazy. What? What? This is so fun. You have no idea how fun this is. This is what you do when you're cool on a Friday night. Okay, so I want to take a step back and basically the next portion of this, which is very short, it's like probably 3 minutes, I wanted to pull out a few different bits that I thought were back to the future, in the sense that these are some concepts and ideas and abstract kind of structures that I've come across within Web 2, both in security, DevOps, etc. And it's reassuring to know that there's a lot of things being copied and pasted over from Web 2 to Web 3, but they're doing it in a way that is fundamentally different than how we've always done it, which kind of makes sense. But it's not completely new. And that's kind of what I wanted to mention here and kind of call out from some of the concepts I've come across specifically in security and DevOps. That being said, let's continue down. In Solidity 201, it's not 102, it's 201. I can't believe you let me do this the entire time with the wrong title. It's ridiculous. And in Solidity 201, there's this ERC 777. And inside of ERC 777, they mention the concept of hooks, specifically referring to hooks as a method of delegating authorization to automated operators. Here in the definition, you can see I kind of jot that down. So with the hooks inside of this proposal of this type of ERC, it's not a token, but maybe it's a token, I don't know, ERC something. And basically it's stating that you have the ability to automate the receiving and sending of tokens through functions by delegating the authorization to operators to work on your behalf. So these automated operators are like little autonomous agents, similar to the smart contract conversation we had in ETH 101. And with these operators, we're authorizing them to make decisions on our behalf. If we receive a certain token or receive a certain amount, we'll take an action or we'll accept it automatically without us having to intervene at all. Same thing with sending. And what this reminded me of was actually within DevOps, and specifically securing DevOps, there's a series of security tests and operational tests and things that you can do once you've committed code. And here's a simplistic diagram that kind of shows this, where you're writing your code and then you decide to commit that. Once you've committed that, there's a series of usually GitHub action hooks or GitLab hooks or things like that that are event driven. So an event occurs and then I take an action, aka GitHub Actions. And you can see there's continuous integration, continuous development. This isn't a DevOps video, but what I wanted to kind of explain is once this action kicks off, there's a series of steps that happen. So we build, we test, we integrate, review, blah, 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 blah. And that's the same concept for this here. When you're thinking about the hooks within this ERC 777, these hooks are basically allowing us to do these automated actions just in association to transactions being sent, received, and then also those transactions potentially being diverted to other contracts. So that was another concept mentioned in here where if I send a transaction here, say to this box has an automated reaction to say, if this specific type of transaction coming from this source, et cetera, then I'm going to divert that to another box over here. And then that could be the same thing. We have a knock-on effect going on. And it's just really cool, really interesting. And I'm glad that it was something I understood pretty easily, I think. Now, this is me mentioning back to the future. So a lot of these concepts here are concepts that are traditionally, within security. And this is basically just another variant or a different way of doing things. And that one piece that I wanted to mention here is emitting events. You'll see within a lot of contracts, specifically I mentioned at the very top of this, we talked about how the structure of a source file should be structured a certain way. One of those items was an event. Those are usually further up in the contract in the beginning. And as those events are emitted, there's listeners. Here you can see there's a series of listeners that are listening. And those listeners are usually dApps. They're usually some sort of analytics dApp sitting on top of the blockchain or different items to index data that's being kind of emitted throughout for logs to track different types of things. So specifically, if you send a transaction, right? So you have A, B, you've sent a transaction. Within you sending that transaction, usually there's a few different items that are emitted, and those items are usually objects. Those objects that are emitted are then logged. And those are logged because there's listeners listening, hence the listeners here. So we have our emitter, our event that was emitted, and then listeners that are listening, and then are basically gathering that information either in index tables or raw graphs, and then they're going to be able to kind of do analytics on top of that and also take actions based off of it. That's something that we do a lot in security today in Web 2, is a lot of logging and tracking events and all that stuff. So that was kind of nice to see that within kind of the blockchain ecosystem. Other thing here is access control and authorization. So access control is something I'm sure anybody in security knows a lot about and is very intimate with. Open Zeppelin, I've already mentioned this above. Remember how we had our contracts that were ownable, and those contracts had modifiers that then had the only owner piece? Well, that's basically a simplistic version of an access control, saying that if actually, let me go back so you don't forget, because I would forget if I were you. I'd forget. So I'm going to come up here, and I'm going to hopefully not make you sick. Remember this page here? We talked about modifiers, how you have a modifier, and if that modifier requirement is not met, that the function cannot go. Well, that is an access control that we have set up here, where we're basically saying that if the sender is not the owner, you can see that here, it's really tiny, I'm sorry about that. We're basically saying that if the sender is not the owner, then do not continue. If the sender is the owner, then I want you to continue this function down here. That is an access control, simplistic. But in addition to that, Open Zeppelin has that access control as well as role-based access controls are back. And those role-based access controls, I actually have a code snippet here to show you what that looks like. This is the basic modifier that I was mentioning. So we have our code snippet here. So the ownable contract is what we've inherited, and then we've basically taken that modifier and said, as long as this requirement is met, then I want you to do this stuff. I already talked about that. But RBAC, here we go. So here is an example of what a role-based access control looks like with Open Zeppelin's kind of setup. And I don't know, I can't explain all the details, but I got a general idea. So here we're inheriting ERC20 and ERC20 detailed stuff. This is probably coming from Open Zeppelin, as you can see here. Also, we're going to basically say we're going to use roles from roles.role. Once we've done that, we're actually going to create some roles. So that role is called Mentor and Burner. And those are the roles, that's our RBAC piece, right? So we have our roles, and we need to associate capabilities and actions to those roles. So if we come down here, we can see that our mentor, an action, so we have add mentors. So we're basically saying if there is no mentor, we want to add a mentor. If there are no burners, we want to add a burner. And if we go a bit further, there should be some stuff down here where we say, okay, so this is basically stating that the mentor, so if the sender is a mentor, then you can take these actions. So that's basically, we're ensuring that this capability is only accessible through a specific role, which is a mentor, and that's part of our RBAC concept, right? So this is something we know within security. We're just incorporating it into Web3 concepts. Same thing applies for this one here. So instead of a mentor, we have a burner, and this is basically saying that, if the sender has the role of a burner, then we're going to allow them to burn a set amount from whatever location. But if they don't have that access in that role, then we're going to basically state that they need to go take a hike. And that is the concept of RBAC and access control. Hope this is useful. I'm loving it. All right, next is authorization. This is the last one. So with authorization, there's this thing called Dappsys, or I think it's like DAppTools. I think I have it linked here. Yeah, DAppTools. And DAppTools has a bunch of tooling. I think this is kind of like a pipeline/security thing. And here you can see there's a mention of a few different tools down here for smart contracts. A few that we mentioned here. One of those is auth, so DS auth. Auth is basically authorizing, pretty straightforward. So I'm going to read this out for you. The auth modifier provided by DS auth triggers this internal function to require that the sender is authorized. So there's an internal function from this tool that's basically checking that the sender is authorized to do whatever action. So this is a form of authorization. In addition to that, there's another tool that works in conjunction with this tool, acting as basically an authority figure. So you can see that mentioned here. It's acting as an authority figure. Let me take this out. So our dguard is an authority figure to our dauth. So we're checking authorization here. In this dguard, we have an access control list. So an ACL, this is something I'm sure a lot of people in security have heard about and used a lot of. And there's a table, there's a lookup table. So we're basically checking that the individual that was authorized, or contract or human that was authorized, we need to look at this table and see what access they have that we can give them. So we're going to look at a table, which is calling from a function, and that function is going to be a simplistic check. And the check's going to be looking for a few different things. So it's going to basically look at the source address, and they're going to say, is the source address, can it be permitted or forbidden? If it is permitted, then what function signatures does that address have based off of the destination it's going to? So we have our source where it's coming from, the destination it's going to, and the function it's allowed to access and execute on. And this is going to return us a Boolean true or false. If it comes back false, we don't give them access. If it comes back true, then we give them access based off of their source, destination, where they're going, and what they're trying to do. All right, and that, I think, is it, Internet. We did it. Well, with that being said, I hope this is useful. I feel like I've explained it somewhat comprehensively, and I will see you on whatever is next in this bootcamp.